Okay, so today we'll talk about compound angle formulas, and the idea is that you're going to use these compound angle formulas. There's four of them. I've written them here. I'll show you why they are true in class, but in the video I'll show you how to use them to find the value of things such as sine of pi over 12. So in section 4.2, we learned how to solve for things like sine of pi over 3, pi over 4, 2 pi over 3, 2 pi over 6, 5 pi over 6. So things with a denominator of 4, 6, 3, and 2. But we haven't yet learned how to find the sine of something other than that, if it has a different denominator. So you would use these formulas to find things of different, to find values where they have different denominators. So for example, sine of pi over 12 has no denominator of 4, 3, 2, or 6, but we can rewrite sine of pi over 12. And this is how you would proceed. You would try and figure out what pi over 12 is as far as the sum of two other angles or the difference of two other angles. And so the idea is that I can rewrite this as sine of, let's see, 4 pi over 12 minus 3 pi over 12. And I know that the sine of pi over 12 is actually equivalent to 4 pi over 12 minus 3 pi over 12. Okay? And that hopefully makes some sense. And then what you do is you take and you reduce these fractions here. Now 4 pi over 12 can be rewritten as pi over 3. Oops, I need to write sine of pi over 3, and 3 pi over 12 can be reduced to pi over 4. So basically the idea is that you need to rewrite pi over 12 as the sum or the difference of two other angles. Those two angles both must reduce into more simplified fractions. And now pi over 3 minus pi over 4 is actually pi over 12. And so what I have here is sine of, I'll write it more clearly here, minus pi over 4. And so I've rewritten it. Now you notice we've got the sine of the difference of two angles. And if we look at our compound angle formulas, and I look at this one right here, I can see that the sine of the difference of two angles is actually equal to this. And so what I'm going to do is I'm going to write down sine of x minus y is equal to the sine of x. In this case, x is pi over 3, and y is pi over 4. And so I can rewrite them And now I'm just going to say that this whole thing is actually equal to the sine of x. X is pi over 3, or the sine of pi over 3 times the cosine of pi over 4 minus the cosine of x. X is pi over 3 times the sine of pi over 4. And now each one of these things I can figure out with the skills I know from the previous sections. Section 4-2 to be exact, with the special angles and all of that stuff. And so now I just try and figure out, I can draw angle pi over 3, and I can draw angle pi over 4, and I can figure out all of the sines and the cosines of those things. So I'll figure out pi over 3 here, and pi over 4 I'll figure out here. Pi over 4 tells me that it's square root of 2 over 2 divided by the square root of 2 over 2, 1. Pi over 3 is the square root of 3 over 2 and 1/2, and this is 1. So this is pi over 4, and this is pi over 3. And then I'll just figure out what each of these are. And write them in there. Noting that in here is multiplication and right there is subtraction. And so the sine of pi over 3 is here. If I go for the opposite, it is the square root of 3 over 2. The cosine of pi over 4 is here, and it's the adjacent, so it is the square root of 2 over 2. The cosine of pi over 3, if I go back over to pi over 3 here, the cosine tells me to get the adjacent side, and so it's 1/2. And the sine of pi over 4 tells me to get the opposite side of pi over 4, which is the square root of 2 over 2. And so in the end, this is what sine of pi over 3 minus pi over 4 is, which is sine of pi over 12. So in the end, I'll write it up here. Sine of pi over 12 is equal to the square root of 3 divided by 2 times the square root of 2 divided by 2 minus 1/2 times the square root of 2 divided by 2. And now if I attempt to simplify this fraction here, it's actually going to be reasonably simple. Remember, I just took this and set it equal to my original, because sine of pi over 12 is equal to this, which was reduced to that, and that is equal to that according to a compound. This is equal to all of this according to a compound angle formula, which I indicated up here. And then each of these parts of the compound angle formula are equal to these ratios due to the unit circle. And so we go and try and solve this. Now, square root of 3 times the square root of 2 is the square root of 6 over 4 minus 2 square root of 2 over 4. And then these already have common denominators, so I can just add them. Square root of 6 minus the square root of 2 over 4. And that's as simple as it becomes. You can calculate this in your calculator and get a decimal value as well. And this is what the sine of pi over 12 is equal to. Okay? And so, in the end, we basically use the compound angle formulas and skills that we previously learned for the special angles to figure out what the sine of pi over 12 is. One thing to note is when you rewrite pi over 12 as the sum or difference of two angles, those two angles must simplify down to an angle and another angle that you can use the special angles for. So they must simplify down to a 3, a 4, a 6, or a 2. Okay? And that's basically the idea. I'll just leave that as the example because they're all done exactly the same way. Alright? It's compound angle formulas.